All right, hello everybody. Welcome to the second lecture of Math 199. So today we're going to talk about subtraction. This one will be a little bit shorter because I'm just going to do subtraction. So let's remember what we did in addition. Okay. So if we have something like 3 plus 4, we talked about putting them together to make 7, right? We just count how many do we have in the first number, how many do we have in the second number, how many do we have when we put it all together. And when we have like 53 plus 88, 8 plus 3 is 11, right? So we have 11 has a 1 in the ones place and a 1 in the tens place. So the 1 in the ones place goes with the other ones, but the 1 in the tens place gets carried over. So we have 1 plus 5 is 6, plus 8 is 14. Right, so we get 141 at the end. And then one thing I don't think I actually mentioned this in the other video, we call that 141 the sum. So the sum is another word for the total, right? The total once we add things together. So this is how we do addition. What about subtraction? Well, subtraction's basically the opposite of this. If 3 plus 4 is 7, then that implies 7 minus 4 is 3. But why? Why does it imply that? Well, first we can check to make sure 7 minus 4 is 3. You know, if we have 7 blocks, okay, we got these 7 blocks. If we take 4 of them away, then we're left with 3. So it does make sense. But the reason that 3 plus 4 equals 7 implies that 7 minus 4 is equal to 3. Well, it's kind of like algebra in disguise, like linear equations. But it's because it's addition and subtraction are like kind of opposites of each other. They're inverses, meaning subtraction is how we undo what we did with addition, right? If we have 3, okay, so we have 3 like on the picture here. If we add 4 to it, then that's how we get to 7. Now, to get back to 3, we subtract that 4, and now we're back at 3. Okay, so they're complete opposites. They're undoing each other. So, in this sense, subtracting with single digit numbers is basically just counting, just like adding with single digit numbers. So if we have 10 minus 6, again, we're just going to count. If we have 10 of something and we give 6 of it away, then how much is left over, right? So let's say, let's say we have $10. Whoops. $10 in singles here. So here's $10. Some dollar signs on there. Now we spend 6 of them. Okay. So we get rid of these 5 and then one more to make 6. Now, how much is left over? Well, $4. Okay. So 10 minus 6 is 4. So it's just counting. We want to take the biggest number and count it out, and then take away the second number, at least for now when we're not talking about negatives, and then see how much is left over. Okay. The number 4 here, this is called the difference. So with addition, the total at the end is the sum. With subtraction, the total at the end is the difference. So we'd say 4 is the difference of 10 and 6. Okay. So, that's fine for single digit numbers. It's counting. For bigger numbers, we could do the same thing. We can count, but again, it gets really tedious, just like it does with addition. So we need a better way. So what's the better way? Well, let's look at our 15 and 12 again, because they make a pretty easy example again. If we have 15 minus 12, well, let's think about, in the same way we did with addition, can we just subtract the ones and subtract the tens? Let's try it and see what happens. 15 minus 12. Okay. Well, if we subtract the ones, if we have 5 ones in the first one and 2 ones in the second, then the difference between them is 3. Now, if we have 1 10 in both of them, then we subtract, we get 0. So we could either write a 0 or we could just write nothing, because it would be the last digit here. We don't really need to write it. But I'll put it there just because that's kind of what we would naturally do. So our answer here is that we have 3 ones overall. And that makes sense. If we have 15 of something and we take away 12 of them, then yeah, we should have 3 ones. So it does work, in the same way that it works with addition. Now, just like with addition, we had the problem where we ended up with too much and we had to carry it. In subtraction, we kind of get the opposite problem. Sometimes we don't have enough and we have to borrow. Okay, so we have to do the exact opposite of carrying. Let's think about 145 minus 39. Okay. So, I lined up the place values already, just like we should. But when we go to do that first one, we're trying to do 5 minus 9. And, we're not talking about negative numbers yet. We're only looking at whole numbers. So this doesn't really work. So what do we do? Well, before we were able to take that extra 10 that we had and carry it over into the tens place. Now we want to do the opposite. We want to say, okay, well, there's 4 tens on that first number in the 145. So what if we just take one of them, so we're left with 3, and bring it over to the ones place? So now there's 15 ones instead, right? Having 15 ones is the same thing as having 1 10 and 5 ones. So we can kind of mix between them like that. So now there's 15 ones, and we subtract 9 of them, then we're left with 6. So it allows us to actually do this problem. So this is what we call borrowing. Okay. So borrowing is like the exact opposite of carrying. And now we just go down the line. Okay, we only have 3 tens left, and we subtract 3 of them, so we have 0. And we have 1 100. We have no 100s in the second one, so 1 minus 0 is 1. So we end up with 106 as our final answer. Okay. Now I want to show 2 different ways to do subtraction. This is the more traditional way that's been taught in school for a long time. It was taught, in when I was in elementary school, and I'm sure it was for most people. But if you've gone to school more recently, you might have seen some other methods that are commonly taught in the new Common Core methods. This is the first way, borrowing. The second way is called, I don't know exactly what it's always called, but I call it adding up. Okay. So this aims to take a subtraction problem and turn it into an easier addition problem. And it's kind of useful because this is really people who are very good at doing math in their head, which I wouldn't even say that I am, but people who are really good at doing math in their head typically do it this way, do subtraction this way, because it's faster to do mentally. So the idea here is with 145 minus 39, we start with the lower number, the 39, and we add numbers to it until we get to 145. So the idea is to make the numbers as easy as possible. Like, for example, it's very easy to add 1 to this to get 40, right? And then if we take that 40, we can add 60 to it to get to 100, right? We're keeping the numbers very easy here. And then we could take that 100 and add the 30 to it to get to we want to get to 145. So, I mean, we can just add the rest of the 45 here. And then the subtraction answer is this addition problem right here. 1 plus 60 plus 45. Okay. It's not really lined up well, so let me line it up better. 1, 60, 45. So 1 plus 0 plus 5 is 6. 6 plus 4 is 10. So we end up getting 106, which is the same thing we got over here. So both methods have their advantages. This one is, well, for one, it's probably what more people are used to learning. So it's fine. And some problems are easier in this way. This way is much easier to do mentally because we're using easy numbers. And typically addition is thought to be easier than subtraction. So let me give you some examples where the borrowing method is worse than the adding up method. Here, I would say they're about even, right? We had to do about the same amount of work to do both of them. One good example is 18 minus 9, right? Here, if we try to borrow, right, because 8 is smaller than 9, if we try to borrow, then we have, take the 1 from here, put it on here, and now we have 18, and now we have 18 minus 9, right? So it doesn't really work here at all. We would just have to count. And it's fine because it's a small number, but it shows that, there are limitations here. Now, before I go into another example, let's talk about what happens if we try to borrow from 0. Okay. So what if we have, let's make it a little bigger, 205, and we want to subtract 78. Okay. We would want to borrow again, but we can't. At least not at first glance, because if we look at the 5 and we go over to the tens place and try to borrow, there's nothing there, right? It's already a 0. It's already depleted as much as it can be. So what we have to do here is kind of double borrow. So we go over to the 2 and take one of the 100s from there. So 100 is equivalent to 10 tens. So we take one of those 100s, and now we have 10 tens. Okay. Now we can borrow from that 10 to bring it over to the ones to get 15. So first we borrow from the hundreds, then we borrow from the tens. And now we can do the subtraction as we normally would. 15 minus 8 is 7. 9 minus 7 is 2. 1 minus nothing is 127. Okay. So that one's fine. If we were going to do the add up method here, it might be easier because we wouldn't have to do the double borrowing. We could do 78 plus 2 to get to 80. 80 plus 20 to get to 100. 100 plus another 100 to get to 200. And then 200 plus 5 to get to the 205. Okay. And now we take this part add them together, 2 plus 0 plus 0 plus 5 is 7. 0 plus 2 plus 1 plus 0 is 3. And then 1. Oh, I'm sorry. See, I have them lined up badly. It should be 0 plus 2 plus this 0 plus 0, because we're looking at the tens place. And then 0 plus 0 plus 1 plus 0 to get 1. So we're at 127 altogether. So that's the importance of lining them up. So which one of these is easier? I mean, it's really just a matter of preference. I don't care which one of these methods you do. Let's look at, now that we know this, there's another good example of where the add up method is a little easier. You know, if you wanted to do something like this, well, it doesn't even really make sense to write this out because, you know, usually we can look at this and know that it's 1. But if we did do the borrowing method, we would kind of have to, well, like quadruple borrow, right? We have to borrow from the thousandths into here. And then we have to borrow from the hundreds. And then we have to borrow from the tens. Ultimately, so we can do 10 minus 9 is 1. The rest is all 0. So we just get 1. Right? So that it can be tedious. Whereas with the count up method, you can easily go, okay, we just add 1 to it. That gives us 3,000. Okay, so this is a bit of a hyperbolic example, but it does show that there are advantages to both. Like, I mean, if we didn't even make it so simple, if we did like 3,000 minus 2285, for example, even this would have the same drawbacks where we'd have to do all of this borrowing to get 5. 9 minus 8 is 1. 9 minus 2 is 7. And then we get 715. Whereas if we do the count up method instead, we could maybe add 15 to get to 2300. And then we could add, where are we going to 3,000? We could just add the other 700. Right? And then right here, we just are looking at 700 plus 15 is 715. So in my opinion, this way is easier in this context, but this method might be easier in some contexts, like arguably in this one, for example, or in this one, this wasn't so bad. So which method you want to do is completely up to you. Okay. So let's talk about multiple numbers. Again, if we want to subtract multiple numbers, we do have to be careful here that we're not going into negatives. So let's say we want to do 123 minus 73 minus 7. Okay. Honestly, we don't normally even set it up like this because subtraction isn't as straightforward as addition. I think the way we normally would do this is we would just do the 123 minus 73 first and then subtract the 7. Break it up into 2 problems instead. You could maybe technically do it this way, but I don't know how well it would work out, if I'm being completely honest. Let's go ahead and try it just to see what happens. We're going to do 3 minus 3 is 0, and then we're not going to have any left over for the 7. So we should probably go ahead and borrow first. Okay. So 13 minus 3 is 10, minus 7 is 3. Now we need to borrow again, right? And then we do 10 minus 7 is 8. I mean, sorry, 10 minus 7 is 3. And we get 33. So it does work, but you have to have a little bit of foresight. Like you have to know that, okay, you need to borrow in this first step in order to get this to work. An easier method for any more complicated examples, probably just do this subtraction first. You get the 0, you do your borrowing to get your 12, and then you end up with 50. Now do the second subtraction, the 50 minus 7, with your borrowing, and you get your 43. Okay. So with addition, it's really no problem just to do it all at once. So subtraction, I would recommend breaking it up into separate problems instead. Okay. All right, so there's not much more to go over with subtraction here. So just make sure you're comfortable with this. Do a lot of practice problems, and let me know if you have any questions. And I'll see you guys next time where we're going to talk about multiplication and division. So thanks for watching.